And so we can go to the QA session now. Maybe we can go through Slack. Raj, did you have a look, or should I do it maybe?
Yeah, as Oliver was saying, there's been a bit quieter. I guess it's been more instructional today, and hopefully everyone's got their setups together. The most recent question is from Gia Kangson. I'm just saying your username out loud. Is in the Gadgetron recon, we don't have code for one, sort of selective averaging, and two, for service call homogeneities. Is there a plan to support these? And Stanislas, you've already offered a response, so I'll give the mic to you to say it out loud.
Correct. So to my knowledge, I don't know if I know all of it about inner and outer average, but that's an option at the acquisition time. But in terms of reconstruction, in ICE, there's only one dimension for average. And so that's considered just one dimension. It just changes the order of sampling. So for Gadgetron to differentiate between inner and outer average, it would not make much sense.
Average.
Je pense que entre autres, je pense que tu vas.
Valerie, you know different stuff? These are the things I know, but maybe other sequences do differently. Valerie?
Maybe it's frozen a little bit. And to answer the second part of the question about surface call homogeneity, the way we treat it normally from the scanner is that the scanner itself has this pre-scan normalize for Siemens scanners options where it will do its own reference scan. And so when you send out the job from ICE, it goes, your reconstruction comes back without surface call corrections, and then the scanner will decorate and update your images with the surface call corrections. So I guess the logic that we based it off is we don't want to necessarily do that in the reconstruction when you're inline, but I guess it will be nice to be able to do it too, but you'll need to take the body call data in order to make those reference changes.
I may add something, is that these corrections that are performed on Siemens scanners in the ICE, it's actually done after the images are sent by Gadgetron. So if you work on this with the surface code and then you have a lot of inhomogeneity on the V1, you can actually do the whole reconstruction with Gadgetron, send out the images back to ICE, and that correction that is embedded in ICE will be performed. And you can actually have the corrected and uncorrected if your sequence supports it.
I don't know if anybody's tried to do this offline. I started trying to do something horrible in MATLAB a while ago, but in the end, it's just much nicer to use a Siemens system. But yeah. And there's a comment I made in the chat earlier. So if you are using non-Cartesian trajectories, I would point out that they will need to be scaled between -0.5 and +0.5. So that's just how the gridding sort of initializer requires that dimension. So if you go over, it will crash, and it will just, the gridding will use the acquisition header to determine what your resolution is. So if you're, depending on which package you're using, I think the Jeff Thesler's NEMFT package requires it to be between -pi and pi. Is that the same for BART too? I don't know. So you might just have to.
Oh, yeah, can you confirm? I think BART is -1.5.
Oh, for BART you have to. It's minus half the matrix size.
Half the matrix size.
That's why we don't have to put any information about the size of the matrix we enter, because it's in the trajectory. And for new FTT, for the GPU new FTT, for example, you have to pass parameters with the matrix size in order to do the proper reconstruction. So I guess that's why they scale the data.
Question for you, Oliver, is in your example XML, you were connecting to an open port, but for most of your use cases, I imagine you actually do a MATLAB execute command rather than having a listening device.
So when the applications are actually being performed, it's definitely using execute. So everything is automatic. If there's no display from MATLAB, you wouldn't even know MATLAB is being called. It's just run in batch mode. The reason for the connect is for debugging, where, as you've seen, it's just so fantastically convenient to just open the MATLAB debugger in this case and inspect the values. When I'm doing parallel processing, the MATLAB debugger does a reasonable job of reporting what the error was from one of the worker MATLAB threads, but it doesn't allow you to just go in and inspect and set breakpoints there. So for that, I would have the switch, which just basically turned off all of the parallel queuing and instead just directly executed the reconstruction step in the employer session.
Okay, thank you. Christopher, I'm just making up questions myself now, but if anybody has more questions, please add them in. But I'm just trying to feedback from my experience in using the MATLAB interface and having not done too much in it so far. But so if you want to install Gadgetron MATLAB from GitHub, you can do, but you need a couple of extra steps to make the Java work.
Yeah, yeah. So there's some Java in there. That is a funny story. We can talk about that, but it's pretty tangential. It's a rabbit hole. Yeah. So if you go to the interface GitHub page, you can get the source, of course, and to have it run, to have it always available to you, you need to add the folder where you keep it to the MATLAB path. Then you have to set the jar file on your MATLAB static path. So there's like a nugget, there's like a little golden nugget of Java code in the middle of the MATLAB interface, because surprisingly, MATLAB doesn't do TCP networking well or at all. So I had to implement that in Java. It means there's a jar file, and you have to set that on your MATLAB static path if you want to install from source. It's not a greatly complicated step, but it's not documented anywhere because I haven't written a README yet. But now it's out there. It's a thing to do. Yeah.
And that's within the Java directory. There's a Gadgetron MATLAB, it's a Java directory in there. You have to just copy the file that's in there. Yeah.
No, so the jar file needs. Yeah, I guess you could move it. I think the kosher way to do it. So there's a file in your MATLAB directory that is sort of a list of static places where it will look for jar files, and you need to add the file to that list. So you just have to edit a text file. It's an extra annoying step, and it happens automatically for you if you just install the toolbox. That works every time.
Yeah.
Yes.
It's a small annoying step, but the advantage is you get all the fresh Gadgetron MATLAB updates. And if you're working in a group with Git additions, then you have that too. And then I guess my last question is, if we were to start from scratch, again, going through our examples, there is the Gadgetron examples. What would be the best one? Because the tiny recon and the bucket recon seem to have slightly different formats. There's the one that uses the while loop, which I think you said was dirty earlier, and definitely the bucket recon is somewhat more modernized or neater.
So dirty is I might have said dirty, but it's too great a word, right? It's just in my experience, MATLAB has a tendency to be one file, 2,000 lines. Half of it is indented at least 3 steps, because you're in an if, then a for loop, then another for, and then sometimes another if. And it's just like, I'm not a very good programmer, and I can't actually read that. Like, it's very hard to work with. So to sort of help myself, I much prefer code that is split up into like nice toolboxes, nice steps. So the simple recon is there to sort of illustrate that you don't have to do the functional programming, you don't have to do the steps. You can just use the interface and have your loops and a large file. But your PhD students will thank you if you structure your code. Well, they probably won't, but at least they won't come asking so many questions. So I guess I would suggest that you have a nice look at the step-based examples. That said, like, I've been talking a lot about toolboxes, having the functions that actually do the work in a nice library where they can be accessed and used in other contexts. And that is done horribly in the examples, right? That's poor. The functions do the work in the examples are just private functions in the step functions. They're sequestered away and nobody can get at them, nobody can use them. So that's a pretty bad thing about the examples as they are now. But I suspect that will change in the future, right? So the examples are living just like the code base. It's all nicely versioned, but it's likely to change. So I think the inner workings of the step functions will move into a toolbox where you can actually get at it. Yes, so look at the steps, but consider having toolboxes instead of private functions.
I would like to say that Christopher actually told a lie there. He is a very good programmer, and you should really pay attention when he's talking.
If he thinks he's a bad programmer, I don't know what his opinion of me would be. So, Val, did you have any questions? I did have a couple more personal ones, but you go ahead if you have anything.
Or perhaps we could open the microphone.
I think we had a question on Slack, actually. So when you run Gadgetron in Docker, it reports that there's no MATLAB support. So maybe we should talk about how Gadgetron detects MATLAB support and how it runs the interface. So there's not a single line of MATLAB code in Gadgetron, like not one line. Gadgetron essentially doesn't know what MATLAB is or how it works or how to interact with it. Gadgetron just knows how to like speak the MRD streaming protocol and establish connections. So what happens when you run Gadgetron info and it tries to work out whether there's MATLAB support? Gadgetron just tries to start a process called MATLAB. And then it sort of looks at the process. It might check if it prints the right things to its standard out, for instance. And it might check if the process sort of exits with a sensible error code. But that's all it can do. So when you run Gadgetron in a Docker container that doesn't have MATLAB in it, it of course can't run a MATLAB process. And then it decides that there's probably no MATLAB support. But you can still very much use the connect directive. Right? So you can still tell Gadgetron to open an MRD stream to whatever address you choose. For instance, MATLAB outside the Docker container. So the MATLAB support no just means that Gadgetron cannot start MATLAB for you. It does not mean that you can't use the MATLAB interface if you're running MATLAB outside your Docker container. Yes.
Another question.
Consume, does the consume function literally consume the data? No, Gadgetron will have access to the data. No. So again, we're back to Christopher 1 year ago. Like he's a pretty good guy, but he makes mistakes. Consume, so it has kept this name, but the functionality has changed a bit, right? So back in the day, consume would call a function, and the function would return a thing, and consume would try to send that thing back to Gadgetron. That has sort of gone away. So now consume just calls a function, and if your function returns anything, it's just ignored. So it's perhaps not aptly named. It doesn't discard your data in any way, but you have to explicitly send it to get it back to Gadgetron and get it to continue down the chain. So if you don't, if the function that you're like feeding to consume, if the function you're having called doesn't send data to Gadgetron, then it just disappears into the MATLAB garbage collector, or indeed the Python garbage collector. There's no consume in Python, but the principle is the same. If you don't send your data back, it just dies in the garbage collector and nobody gets to see it. So you must explicitly send, I guess is the answer.
So I'm gonna follow up here because I think it would be easier. So does that mean if I have data of type acquisition that's coming into MATLAB, we just discussed earlier that that's not something we can send back from MATLAB.
Acquisitions we can. So we can send the basic MRD types. We can send images, acquisitions, and waveforms. So waveforms that's usually EKG data, stuff like that.
Perfect.
Yeah,
thank you.
But you can't at the moment send any of the internal Gadgetron structures. Like that is changing. Say the code is living and we're making improvements. We take pull requests, things are getting better. So Stan has a image arrays coming up, and I'm going to do some recon data soon. So like we're going to have full support of all the data types. It's just not there yet today.
Perfect. Thank you.
And
can I ask Christopher to just elaborate on something which I found very helpful early on learning about the function composition?
yes.
So when you see steps one after other, next equals, next equals, next equals, and so forth, and then finally consume, which is just calling that last next. One way which I found very easy to visualize this was it's just a way of writing in a list what can otherwise be written as nested function calls. So the last consume function has as its argument the previous step, which has as its argument the previous step, and so on all the way up to the connection dot next. So I thought maybe someone would be introducing that today, just to make sure that people have been exposed to that idea. That's what's going on. It's all a way of nicely unwrapping that nested structure. Is that a fair description?
It is. It's very fair. You're sort of creating a chain. So you're creating a chain of closures where each sort of node knows how to get data. So you get sort of you get a chain of functions that receive their input from the next chain. So you sort of have a structure in memory that's very, very similar, at least conceptually, similar to the chain of gadgets in Gadgetron. So it's like we have we've converged on the same sort of structure because it's really very good at like real-time efficiently processing data and getting images back to the client real quick. I mean, I can try to do a drawing, but your description was excellent. I'm not sure it would reduce confusion.
From experience, it does take a while for these concepts to sink in if it's the first time you've seen them. So don't worry.
But I guess it's an important point that if you're not comfortable with lambda functions and higher order functions, you can still just use the MATLAB interface. You can still get a connection, pull some recon data, and just start hacking. It's pretty easy to get going, and you don't have to worry about like writing nice code, I guess. So I try to make an interface that is both like that is simple enough to be used in almost all contexts. So I'd like that to be a clear point. All you need is the connection, call next, get some data, like write some code that does a thing.
Yes, this is something also I think we would like to know. So if you, for the next session, if you try to convert your data to use the Python interface or MATLAB interface, we almost have no idea how much you can follow what we present. So we focus a lot on technical details because it was the purpose of the course. But basically, you can just pick the code, copy and paste what you want to do with your code, and see how it's going through in the Gadgetron. And after you can dig and look for specific features that we present. But you don't have to learn and know everything. We try to cover most of the new features that has been added, but in practice, you don't need to know everything to use it even inline. So but yeah, if you if you have the possibility, we will be really happy to know what you already did, or have some to share. The younger session that Oliver mentioned is also a good place to have some interaction with us and to share your MRI issue with the Gadgetron to do MRI reconstruction. I think if there's no more question, I think we can say a few words about next week. We will, so David and we will present, we do presentation about C++ part. So there will be, I think, high level presentation, but also low level presentation. They will cover all the library that are already present in the Gadgetron and the source tree. Is that correct, David, or?
That is not my plan. I believe Hui is giving an overview of the generic gadgets that are part of Gadgetron and an overview of AI in Gadgetron. And I will be doing a demo of how to write a C++ gadget.
Okay. Yes, this is what it is. So, and okay. And yeah, and we will show how to integrate some machine learning segmentation into the Gadgetron and to deploy it for doing studies that to do multi-center studies. So it's basically dockering, I think, everything, and it can push the image in many hospitals, the NH, and applies this recall and segmentation on many patients. This is quite awesome. Is there any other question? I think we maybe one. No, that's okay.
There's one last question, which is, I mean, Asan, you can maybe ask this directly, seeing there's a question about your question.
Are you referring to? So I might have the terminology wrong, but I was wondering if the external language interfaces support branching. So basically, having parallel threads running.
Yes. So if you wanna if you wanna use the Python external language interface and start a billion Python threads, that's fine. Go ahead. Or if you want to run like parallel MATLAB, that works fine.
What I mean is within Gadgetron, if we have so we're thinking of a chain where if you're doing some sort of for example, like self-gating or something, you have some data coming in and you want to send some of it down one chain, which is processing the self-gating, and the rest of it is trying to do the recon. Can we have that with the external language interface?
Yes, so Gadgetron supports branching chains. So you can split your data in Gadgetron, and on whichever branch of that you want to do processing in Python, you just put a Python gadget or MATLAB. And that'll just work. So all these, there's a lot of advanced features in the config files. So you can have branching chains, you can have chains distributed on multiple machines, you can have, pure chains, and all of this sort of meshes nicely. So everywhere you can have a gadget, you can have an external node and have the data that gadget would see go out to Python or MATLAB. So the short answer is yes. The long answer, I guess, is yes, always.
Perfect. That's great.
The only thing you can't do with Python or MATLAB is the gadget that like splits your data between the branches. That has to be a C++ gadget.
Cool. That sounds good.
I think Hassan also mentioned that his question is, can you replicate the data to multiple nodes instead of just splitting the data? Right? If you want to do self-gating and reconstruction at the same time, you might want to use the same data. Is that right, Hassan?
Yeah, there's I think like there's one of the splitters is called acquisition fanout, and that copies the acquisition down each branch.
Okay, thank you.
Thank you.
Well, there's no more questions. I think we can probably wrap up 10 minutes early. Val's already given us a preview of next week. I will thank the speakers again for doing a great job of walking us through the different reconstruction pipelines. Hopefully these different examples will help you get up and running. And of course, if please apply this to your own data and get sort of into the weeds and let us know any questions you have. Val, do you have anything to add?
No, that's perfect.
Okay, great. Well, then see you next week.